Welcome to Acid-Base Equilibria, Part 3, and I am Ms. Bedrosian, and we're going to just look at one example for this section. Reactions with strong acids and strong bases. These are kind of simple. And here is the example. 28.0 milliliters of a 0.25 molar solution of nitric acid is mixed with 53.0 milliliters of 0.320 molar solution of potassium hydroxide. And you are going to have to make several calculations. I'm going to give you the answer at the end. But I'm going to walk you through the steps. Step 1 is always right. The balanced equation. That is always step 1. Step 2, write the net ionic equation. So you know what it is that we are looking at. This one's easy. You know it's neutralization. Step 3. For step 3, I want you to determine the number of moles for each, the H plus and the OH negative. Step 4, you need to figure out which one is the limiting reactant, because that's what this is based on. There is a limiting reactant. You need to figure out which one. Step 5, I want you to determine how much of the excess reactant there is. So how much of it was used up? Then determine how much is left over. And for step 6, I want you to find the resulting molarity of that excess. What's the molarity of the excess reactant at the end of the experiment? Pause and come back to the answers. All right, here come the answers. This is step 1. This should be your balanced equation, as you can see it. Simple enough. And step 2 was the net ionic. Also, this should be the easy step as well. And here is the net ionic equation. H plus OH negative yields water. For step 3, I want you to determine the number of moles of each of those. So to do that, change that to liters times the molarity, that's moles per 1 liter. And for the hydrogen ion, you get 7.00 times 10 to the negative 3rd moles of hydrogen ion. Do the same, you should have done the same for the hydroxide. That was 0.0530 liters times the molarity that was given to you, moles per liter. And you get 1.70 times 10 to the negative 2nd moles of hydroxide. Compare those two amounts. So the lesser amount determines when the reaction stops. That is the limiting reactant. In this particular case, the limiting reactant is H plus. That is a smaller number. When you reach that number, it means all the hydrogen ions have been used up. For step 5, you can make the conclusion, since this is a 1-to-1 ratio, hydrogen ions must equal hydroxide ions. Therefore, the amount of hydroxide must be the same that you used up. 7.00 times 10 to the negative 3rd moles of hydroxide is used up. For step 6, figure out how much is left over. You're going to take the starting amount minus the moles of hydroxide, and you will get 1.00 times 10 to the negative 2nd moles of hydroxides in excess. I'm sorry, step 6 is actually figuring out the molarity. And to do that, you have to be aware, remember that's this brackets is molarity, that you now have an increased amount of fluid, so you need to add those liters together. So it's whatever's left over divided by the total liters, and it's 0.123 molarity. Actually, it's a really fun number. Take a look at your calculator. It's pretty cool. Don't get that very often. And this is the end of part 3. Welcome to acid-base